Chennai. And she has the additional responsibility of being a Deputy Director, Center for Research, Anna University from 2019. And she is an attestation officer of Anna University from November 2017. And she is the President ISTA, Department of Information Science and Technology, Anna University, Chennai from February 2016. And she is the visiting faculty, a Department of Computer Science and Engineering, College of Engineering, Guindy, Anna University. And she is basically a program officer for NSS also, Anna University from September 2014. And she has the additional responsibility of having Treasurer ISTA, Anna University, Chennai during February 2014 and February 2016. And her area of specialization is language processing, multimedia, and cloud computing. And she has over 7 PhD scholars guided under her, and number of PhD scholars guiding presently is 2. And she has guided over 40 projects in ME Tech, and she has more papers in international journals. 36 papers she has published in international journals, and national journals she has 16. And a very good morning, ma'am. We have a very great academician in our midst today. It is the duty of us to introduce her on behalf of the Sairam group of institutions and the Sairam Engineering College. The Department of Computer Science and Engineering, Sairam Engineering College welcomes you, madam. Over to you. Thank you, madam.
Yes. So good morning to one and all present here. First of all, I would like to thank Sairam Engineering College, Department of Computer Science and Engineering for inviting me for the strategy development program. So let me share my PPT. Is it visible, sir?
Yeah, ma'am. It is visible, ma'am. Your voice is clear. It is visible, ma'am.
So shall I start?
Yeah, ma'am. You can start, ma'am.
Yes. So the topic that has been given to me is AI-enabled IoT. So I'm not basically an IoT person, but I'm an AI person. So I thought I can talk on how to mix up this AI with IoT to develop some kind of smart applications. So the agenda of my talk will be the definitions for AI and IoT, what AI is and IoT is, and then some of the applications related to AI and IoT, like smart cities, smart agriculture, smart healthcare, and smart education, are the 4 applications that I have taken. So we'll have a short discussion about all these things. So let us start the discussion about this AI or the artificial intelligence. What is this AI? This is a simulation of human intelligence and mission that are programmed to think like humans and mimic their actions. Okay. So what is this artificial intelligence? We try to incorporate some kind of intelligence to the machines to make them think like human or to make them work like human. Okay. So this term may also be applied to any mission that has traits or it exhibits traits associated with a human mind. So algorithms also play a very important part in the structure of this AI. There are simple algorithms used in some kind of simple applications, and complex ones are used in complex application to develop some kind of AI-enabled applications. There are various algorithms that are there, which are helpful in making an application a step forward in making an application enabled, AI-enabled, or making an application work with lots of intelligence. We have various algorithms, simple algorithms as well as complex algorithms. We'll just look into all these things. So other examples of machines with AI include the computers that play chess by themselves and the self-driving cars. So nowadays people are talking about self-driving cars, which is an example of AI-enabled application. Okay. So now coming to this thought process and the behavior. So what is the thought process of an AI-enabled application? The systems that they think like human beings. The systems that they try to make decisions. They try to make some kind of analysis like human beings. We call them as AI-enabled missions. Okay. And then we try to include rationally to it That means the system that think in a rationally in the sense, like they think in a logical manner, a sensible manner. Systems also think in a logical and sensible manner, and they also think like human beings. We call them as AI-enabled machines. In terms of behavior, we say that the systems that act like human beings, okay, or the systems that act rationally as well as they act like human beings. They try to mimic the human beings with some kind of sensibleness, or logically they try to mimic the human being. We call them as AI-enabled machines. Okay. With this in mind, let us, I think already you could have known about this IoT. IoT is a system of interrelated computing devices like mechanical and digital machines and objects and people that provide with everything, animals, objects, or whatever it is. They are all provided with some kind of unique identifiers. Okay. And they have the ability to transfer the data over a network without requiring some kind of human to human interaction or human to computer interaction. Okay. So we call this kind of interconnecting devices, any device that is there in the world, the devices are being interconnected with each other. So then how do we access any kind of device? With the help of some kind of unique IDs associated with that device. So when all these devices are interconnected in the form of a network and they try to transfer the data over the network, and there is no human to human interaction or human to machine interaction, we call it as a integrated or interrelated computing device, or integrated IoT information, the Internet of Things. An IoT ecosystem consists of web-enabled smart devices that also use embedded systems such as processors, sensors, as well as a communication hardware. They try to collect the data, send the data, and act on the data, and they acquire what they acquire from the environment. IoT devices also share the sensor data they collect by connecting to an IoT gateway or other edge device, where the data is either sent to the cloud to be analyzed or it can be analyzed locally. So if you look at this is an example of a generic IoT system. So if you look at this generic IoT system, you can see here is a data collection process happens here. There from various IoT devices or from various, like in the first statement, we have seen that all the computing devices are connected together, whether it be objects, not only computing devices, it can be even objects, animals, people, all are provided with unique IDs, and they have the ability to transfer data with the help of sensors. So all the devices, IoT devices are here. So I try to collect the data from all these IoT devices with the help of, say, sensors or antennas, or with the help of some kind of microcontrollers. And then we collect the data, we collate the data, and we try to transfer the data over the hub. Okay. So this is a location where we call it as a edge computing, where the edge computing happens here. I try to collect the data, I try to collate it, and I try to transfer it. Either if it is a small or medium amount of data, it is possible for me to process it at the edge itself. If it is a huge data or a big data, I try to give it to the cloud for some kind of analysis or for process. So the analysis and the action taken happens at the cloud. Okay. So here you have the user interfaces. So the user interfaces can be in the smartphones, or you can access it using the smartphones, or it can be some kind of human mission kind of interaction. And then you have lots of business analytic application running here, and then you have the backend systems. Okay. So this is a generic example of an IoT system. So in this kind of generic IoT system, we are going to incorporate some kind of intelligence. This kind of IoT system can be created without intelligence or with intelligence. So if it is with intelligence, then we'll see how far it is better or how far it is going to perform when compared to an IoT system without some kind of intelligence. Okay. So what is the need for AI in this IoT? So AI is a key to unlock the IoT potential. If you see, the major vendors of IoT platform software now offer integrated AI capabilities such as machine learning based analytics. Okay. So if I say incorporating AI into IoT, I'm talking about giving some kind of intelligence to the machine, which means we have various machine learning algorithms that are available. Nowadays, people are talking about deep learning algorithms like CNN, RNN, things like that, where we try to make the system learn, make the system understand, make the system or train the system. And based on the training that has been given to the system will respond for some kind of test data that is given later. Okay. So this is how we try to incorporate the artificial intelligence into the mission. So the value of this AI in this context is its ability to quickly wring the insights from the data. So some examples are like predictive maintenance using the analytics to predict some kind of equipment failure. In the case of process automation, we can think of equipment failure that is going to occur ahead of time. You try to, that is going to occur later, and you try to predict it ahead of time in order to schedule the orderly maintenance procedures. And you can also mitigate the damaging economies of unplanned downtime. Okay, so then this kind of machine learning makes it possible to identify patterns in the constant stream of data from today's machinery to predict any kind of, it can be equipment failure, or it can be process failure, or it can be any kind of failure that is going to happen later. We try to predict it before itself, and we try to plan how to accommodate such kind of failures. Okay, then we have number of application pairing IoT and AI, helping the organization better understand and predict a variety of risks, as well as automate for rapid response, enabling to better manage the worker safety, financial loss, and cyber threats. So IoT and AI, when combined together, they help in better management of machineries. Okay, rapid response will be there. They try to manage the worker safety, can be ensured, financial loss can be predicted and that can be avoided, and some kind of cyber threats can also be predicted and can be avoided when we try to incorporate AI into IoT applications. So if you see here you can see that we have IoT, big data, and AI as three different nodes. So IoT devices, from the IoT devices, we try to sense the data, and the sensed data are being saved or are being collated in the form of big data. Okay, using this big data, we try to train the AI/ML algorithm. Okay, the machine learning algorithms. We try to train the machine learning algorithms based on the training that has been given to these kind of AI/ML algorithms. The commands are given to the IoT devices to act in an intelligent manner. Okay, this is how the IoT, big data, and AI/ML are integrated with each other. So here, this entire process, you can also call it as big data analytics, because we try to collect the big data from the IoT devices and we try to perform a lot of analysis over the big data. Okay, it can be some kind of predictive analytics, also descriptive analytics or predictive analytics, or it can be any kind of analysis for that matter. And using the analyzed values, we try to take some intelligent decisions. And those decisions are given as commands to the IoT devices to act in an intelligent manner. So some examples, applications, let us look at some applications where AI and IoT are integrated with each other. The first application that I have taken here is a smart city application. So giving an introduction to the smart city, cities are the hubs for economic growth, job creation, new ideas, technological evolution, communication and networking, information and social transformation. There are a large percentage of population that live in cities as well. So a smart sustainable city is an innovative city that uses the ICT and other means to improve the quality of life. We try to integrate the ICT techniques to the city and make it as a smart city. So efficiency of urban operations and services and competitiveness, while ensuring that it meets the needs of the present as well as future generation with respect to economic, social, and environmental aspects. So we try to integrate all the ICT innovations, the technological innovations to the city, so that economically, socially, as well as in the environmental aspects, we try to enhance the city to a smart city. So the specification of a smart sustainable city, a smart sustainable city leverages the ICT infrastructure in an adaptable, reliable, scalable, accessible, secure, safe, and resilient manner. Okay, in order to improve the quality of life of citizens. So what is a smart sustainable city? What are the functionalities of the smart sustainable city? One of the functionality is to improve the quality of life of all its citizens. And it also ensures tangible economic growth, such as higher standards of living and employment opportunities, giving employment opportunities for all its citizens. It improves the well-being of the citizens, including the medical care, welfare, the physical safety. I think there is some kind of distraction in between. Organizers, can you please mute others' mic? So we try to improve the quality of life of citizens, and we try to ensure tangible economic growth, such as higher standards of living and employment opportunities for all the citizens. improve the well-being of the citizens, including giving some kind of medical care, welfare, physical safety, and education, and establish an environmentally responsible and sustainable approach which meets the needs of today without sacrificing the needs of future generation. Okay, this is specification of a smart sustainable city. So how are you going to achieve this? A smart sustainable city leverages the ICT infrastructure in an adaptable, reliable, scalable, accessible, secure, safe, and resilient manner in order to streamline the physical infrastructure based services, such as we try to streamline the transportation, that is mobility services, the utility services like the energy and the water, the telecommunication services, as well as the manufacturing sectors. So in all these areas, we try to reinforce some kind of intelligence so that it becomes smart transportation. We call it as smart energy or smart water management, okay, smart building. Okay. And then we try to reinforce prevention and handle functionality for natural and man-made disasters, including the ability to address the impacts of climate change. It is also possible for us to handle the predict the disasters beforehand itself. And then based on the predictions, we try to take some kind of responsive actions. So this will actually help in improving the quality of the people who are living in kind of cities. And in the case of cyclone also, we have seen, since it was possible for us to predict the kind of cyclone some 2 or 3 days before itself or 1 week before itself, so it is possible for us to evacuate the group of people who are living near the seashore and all those things. So these kind of things are all, we call them as AI-enabled applications. So they provide an effective and well-balanced regulatory compliance and governance mechanism with appropriate and equitable policies and processes in a standardized manner. So whatever we try to do, we have to do it in a standardized manner. So for which case we have to generate the policies, and they have to generate the processes, and all these are supposed to be followed, and it has to be standardized. So when a city is not a smart and sustainable city, what happens? The infrastructure grows, but it is not well connected. The city will not be well connected, which will result in lots of traffic jams. So why traffic jams are coming here? Because when the city is going to act as a smart and sustainable city, so you have IoT devices all over all the vehicles. So all the vehicles will be interconnected. When all these vehicles are interconnected, they talk with each other so that accidents never happen. Okay, there is very meager chance of accidents happening, and you will not have traffic jams also, because we know where the previous vehicle is moving, in what direction it is moving, what is the speed of the previous vehicle. Everything will be known to everybody, so that each and every person or each and every vehicle can adjust on its own, so that traffic jams never happen. You don't miss any buses or trains and flights because of flight timings, bus timing, whether a bus is going to, suppose somebody is waiting in the bus stand for some quali or some kind of bus. So in the bus stand itself, it will tell that the bus is coming. Not only the buses in this particular location, and it will be arriving at some 9:05 a.m. or something. Not only that, it will also tell that whether the bus is full or there are seats, it is empty, or how many passengers are there in the bus. All the information will be given to the people who are waiting in the bus stand, so that they can make a decision based on those information, and they can make a decision whether to wait or whether to miss the bus and go for the next bus and things like that. Okay. So if the city is not a smart and a sustainable city, there will be lack of coordinated response to disaster, any kind of disaster management activities. There will not be any coordination among all the activities that happens. Okay. The sources of information will not be available. There will be shortages of supply in terms of electricity, water, and food. Okay. In case of disaster, and in case of disaster management, if everything are not connected, or if the city is not a smart and a sustainable city, you will have shortages of electricity, water, and food. So, and then you will have duplication of resources. Wherever the resources are not needed, you will have duplication of resources, and wherever the resources are in need, you will have depletion of resources. So all these can be avoided when you try to make your city to be a smart and a sustainable city. So these are some of the identified key areas that have significant impact on the citizens, the society, and can be influenced by the use of ICT, like sanitation. In all these areas, smartness can be introduced. You have sanitation, ICT infrastructure, you have the manufacturing sector. Okay. So you sanitation in the sense that the garbages, that are placed all over the city. Okay, you can attach some kind of IoT devices to those garbages or garbage bins, so that whenever the garbage bin is full, automatically it will send an alert message to the centralized server saying that this particular unique ID, this particular bin is full, and it can ask for the people to come and remove the garbage that is there. Okay, so such kind of, and not only that, similar kind of many applications, like if there is a leakage in the drainage, okay, that can also be automatically alerted to the centralized server if it is an IoT enabled, AI and IoT enabled. Automatically, it will, if it is an IoT enabled thing, it can automatically tell the centralized server that some kind of leakage is happening. If it is an AI and IoT enabled thing, it can automatically also find out for what reason that leakage has happened, and it will also give certain decisions saying that these are certain solutions, saying that these are the solutions that needs to be taken in a fast manner to avoid such kind of leakage. Okay, so then you have the ICT infrastructures like buildings, manufacturing sector, governance, environment, employment and opportunities, health and education, safety and security, real estate and buildings. Buildings can also be made as smart buildings. Nowadays, people are telling that any building can be made as a green building or a smart building, wherein whenever people enter into some particular room, automatically the lights and other things gets on, switched on, and whenever the persons leave out of the room, automatically the lights switches off. Okay, so the ventilation, the AC, the heating equipment in the room, all the systems are, you call them as HVAC, HVAC systems, and all these systems are interconnected. Okay, so that the entire building will act like a smart building. Okay, and moreover, it can also be made as a personalized smart building. Like if I am supposed to, if I am entering into a particular room, even the color of the wall paneling and other things will, the lighting effects, everything will change as per my interest. And if another person is going to enter into the same room, the wall paneling color or the lighting, the light dimness, the intensity of the light and all those things, the color of the light and all those things will change as per the interest of that particular person. Okay, all these come under these kind of smart buildings. Okay, then you have smart transportation also. So if you look at this transportation and logistics, as I said, the fleet management, goods tracking, where exactly the goods is coming. Okay, so how many carriers are there? Where exactly it is coming? Using GPS trackers nowadays, it is possible for us to track these kind of goods and all those things. Then we have smart metering or the smart grid management. There, with the help of these kind of smart metering techniques, it is possible for us to pay the electricity bill, or we'll automatically the electricity bill gets generated at each and every consumer's end, and the consumer can directly pay their bill online nowadays. Okay, so there is no need for any kind of manual intervention, because a smart meter will automatically tell how much amount of electricity units has been consumed by a particular consumer. Okay. Then in the case of smart cities, you can think of parking sensors, waste management, etc. Waste management is the one that I have told, like the smart bins. Parking sensors are the ones there. In the case of malls and other places, whenever we go, we don't know where to park our vehicle, because even though they have some 10 to 12 floors of parking, we start with floor number 1 and we'll be turning here and there or running here and there, so that to find out an empty park slot. So in the case of smart parking mechanism, you can very well, it will automatically tell that these are the places, or here some 3 locations are available, and it will also tell what are the locations where parking is available in that particular floor. Okay, so we have parking sensors, the sensors which will sense whether a vehicle is standing there or not. Okay, and then intimate, collate all the data and tell for the entire floor. If it is for the entire building, it becomes parking smart building. Then we have smoke detector and home automation system. Home automation systems are the ones that I told, like whenever I enter, automatically the lights, the ventilation, the AC and everything gets switched on, based on my interest or based on my own preferences. So then we have the smoke detector. Then at the consumer's end, if you see, we have wearables. We'll be talking about the wearables later when we talk about the smart education also, where it is possible for us to track the kids as well as the senior people with the help of these kind of wearable devices. Then at the industrial end, we have process monitoring and control, process maintenance, whether any kind of failure is going to happen, predicting the failures. Okay, so how the process is going on, monitoring the entire process. And then at the environment end, we can talk about food monitoring, alerts, environmental monitoring, like some kind of climate change. Okay, what about the food productivity for this year and for next year? How much we are going to produce, whether that will be enough for the next year. Things like that can be analyzed. Okay. Similarly, in the case of agriculture, we have climate and agriculture monitoring, livestock tracking. We can also track the livestock. Okay. So all these are some of the key areas that have significant impact on the citizens as well as the society. And these can be influenced with the use of ICT technologies or techniques. So the role of this IoT, AI, and ML in smart sustainable city, if you see.
Ma'am, sorry, ma'am,
Yes.
sorry to interrupt. Madam, 1 second. Participants, can you mute yourself? Participants, kindly mute yourself.
Sir, I think the administrator can automatically mute everybody, sir.
Yeah, ma'am. I'll do.
ஏதாவது கொஸ்டின்னா கூட டயகிராம் போட்டு ஏதாவது எழுதுவானுங்க. அப்ஜெக்டிவ் எப்படி அவனுக்கு படிப்பானுங்க ரியலுக்கு? அப்படியா சொல்றீங்க?
Can I continue, sir? Sir, can I continue?
Ma'am, is it fine now?
Yes, sir.
Yeah, please go ahead. Sorry, madam. Sorry for the
No
interruption.
problem. The role of IoT, AI, and ML in smart sustainable city, if you see the combination of this high-speed, resilient, low-latency connectivity and technologies such as IoT, ML, and AI will enable the transformation towards some kind of sustainable smart cities. So why IoT and AI need to work as a tandem? Here, there are certain applications or certain examples that are given here. So if you see here, we have all the vehicles that are vehicles on the road. Okay, so all these vehicles are interconnected among themselves. So we call this platoon formation. So when a platoon kind of formation happens, what happens is all the interconnected vehicles, they try to talk with each other so that every vehicle will know at what distance or at what velocity the previous vehicle is moving and where exactly it is moving. Okay, and in which direction it is supposed to go. Everything will be known to all these cars or the vehicles that are connected in the platoon, and everybody can then work accordingly so that there will be minimal traffic jam or no traffic jam, and there will be no accident at all. Okay, so this is how all these the entire transport works in a smart manner. Okay, so here also you can see wherein all the devices are being interconnected. Okay, so interconnected, all the devices are being interconnected through the networks. You nowadays we also have some kind of cameras that are placed in all the roads, isn't it? So even the videos that are collected from these kind of cameras, can be collected together and it can be analyzed in an automatic manner. Okay, so that some kind of accident or something happens, immediately it can give an alert message to the nearby police station saying that some kind of accident has happened at a particular location. Okay, so it is possible for us to have some kind of smart city by just having all these IoT devices like cameras and other sensors, collecting all the data from these cameras and other sensors, and we try to analyze the data in an automatic manner. Okay, so if you look at the transportation efficiency, the connected vehicles and smart roadways also provide real-time traffic, transit, and parking data for maximum efficiency and minimum congestion. The real-time parking slot, the real-time traffic data, everything can be noted down. And then it also lowers the operating cost because The operating data and the diagnostics drive preventive maintenance to decrease the cost and improve the warranty and the service process. And it also improves the safety where the vehicles talking to each other enable cooperative crash avoidance safety applications. So here you can see the entire vehicle in the truck is loaded with lots of sensors here and there. You have the humidity as well as the temperature sensor here. Then you have the freight monitoring. Then you have the engine crankshaft rotations. Then you have the pressure sensor, which is going to sense the pressure that is. Then you have the mileage tracker. You have the speed tracker. Then you have the running time. So all these things are being tracked. And these data that are being tracked or that are being sensed or collected, and then internally it is processed and the decisions are given to the vehicle. Not only the decisions are given to this vehicle, it is also given to all the vehicles that are connected in a platoon kind of environment. Okay, wherein the other vehicles will also know at what speed the previous vehicle is going and all those things. So the next application that we are going to talk about is a smart agriculture. So if you look at the smart agriculture, today in India ranks second in the world in farm output, and about 64% of the cultivated land is dependent on the monsoon only. The irrigation accounts for about 55 to 75% of water usage in India. Nearly 60% of the water used in this kind of irrigation is being wasted. So we try to conserve the water by using some kind of soil moisture sensors. Okay, so since irrigation is most important for this agriculture, and we know that the irrigation accounts for about 55 to 75% of water usage in India, and we know we have lots of the water depletion that happens in India, and we need to save the water, isn't it? So for that, we have some kind of soil moisture sensor, which will sense the moisture content of the soil, and based on the soil moisture content, automatically the sprinklers will be enabled or disabled so that it automatically extracts the amount of water needed for that kind of soil. Okay, so we have crop water management. This is one application of IoT in agriculture, where the watering to the crops can happen in an automatic manner and in an intelligent manner. Okay, then we have pest management and control. So the pest, whether the pests are there or not, what kind of insects are there, what is the kind of whether the crop is being affected with some kind of disease or not. All these things can be monitored as well as controlled if it is smart enough. So which means this kind of pest management and control will work well if we have some kind of say cameras that are being fixed, so that which will monitor the entire crop every now and then. And then here and there you fix up the cameras, it will monitor the entire crop, and we try to analyze the images or the videos that are captured by these kind of cameras. And using those videos or the images, we can detect whether any when the leaves are being affected or not, or whether the crop is being affected by insects or not. All these can be detected and can be monitored. Similarly, precision agriculture. Okay, the precision agriculture is an IoT application in agriculture. Then we have food production and safety. Okay, so whether it is possible for us to improve the quality of the food that is being produced, improve the quantity of the food, all these things are different IoT applications in agriculture. A few use cases that are implemented for IoT, if you see, monitoring, we have basic cameras for monitoring the field as well as livestock. Livestock monitoring can also be done using these kind of fixing up cameras here and there. So you have intelligent cameras with the motion detection. Okay, so which will try to, we have a passive infrared detectors, PID sensors also, which will also help in detecting the movement of any kind of livestock or human or whatever it is, or miscreants, and these can be detected, and automatically it will be sending an alert to the central administrator, saying that some kind of an unwanted thing is happening at some particular location. Okay, then we have the aerial monitoring system using drones. With the help of drones, it is also possible for us to monitor the entire crop in an aerial. So the drones are like, they try to fly at some particular level, and they try to take pictures. You fix up cameras, they try to take pictures of the entire field, and then these pictures are being analyzed. This is one thing. And then we have drones also are being used for spraying the pesticides, spraying the insecticides. So I think even that locust for driving the locusts that had arrived from North India, we had used the drones only, which spray some kind of pesticides or insecticides, which will not allow these kind of locusts to enter into our area. Okay. Then for irrigation, we have remotely operated irrigation systems. As I said, the sprinkler system, which can be wherein the mouth of the sprinkler can be opened or it can be closed automatically, okay, based on the soil moisture content. Automatically the mouth of the sprinkler can be either opened or closed. Then we have smart irrigation controllers like sensors, forecast, the plant care information, soil moisture, leaf wetness, the temperature based automation. We can also have temperature sensors which will measure the temperature based on the humidity, based on the soil moisture content. You can irrigate the plants in an automatic manner. Then we have automation in aerial planting techniques to sow the seeds. Okay. For seed sowing also nowadays, the entire automation is happening. They are using machineries, they are using drones to sow the seeds also. Then we have pest detection using infrared sensors. We have infrared sensors which can detect the pests that are there on the leaves or on the plants, and we have the harvesting techniques for crop readiness detection and automation. So these are few use cases that are implemented for where IoT is being used in agriculture. A few emerging agricultural use cases are crop protection using early prediction system with data crunching. Okay, so this we call it as an AI-enabled application where you try to predict. Okay, so it is like some kind of predictive analytics. We try to predict whether this crop is being will be affected in future or not. Okay, so based on that, you try to apply certain kind of crop protection mechanism. Okay, then we have harvesting predictions using customized crop monitoring techniques. So harvesting predictions can also be done like this month how much will be the harvest, next month how much will be the harvest. This is based on the data that has been collected from the crop that is being monitored over a period of time. Then we have IR camera and heat sensor based on night predator protection. So some kind of night predators or pests that enter at night, or locusts or insects that enter into the field at night, all these can be captured by the help of IR cameras. Cattle tracking using GPS based sensors. So you try to fix up certain GPS sensors on the livestock or cattle so that you can track the cows, the sheep or the goat that grazes the fields. So all these things can be tracked. Then you have an Uber-like app for agri vehicles and equipment to track the agri vehicles where the vehicles are present. Or say for example, I am a farmer, I have harvested a lot amount of crop this winter, so I would like to transport it. So I can have an Uber-like app and I can see where the vehicle is. I can call the vehicle, so that vehicle automatically comes, it picks up all the goods that are available, and then it transports it to the whichever place where it is being marketed. Okay, so this is an Uber-like app for agri vehicles as well as equipment. Then we have pregnant cow monitoring using tail sensors. This is also another one emerging agricultural use cases wherein you can monitor the pregnant cows or the pregnant livestock. Okay, so all these things are some emerging agricultural use cases in the case of IoT. So as we said, the crop water management, where usually the farmer pumps the water, and since the farmer is going to pump the water, he doesn't know how much amount of water is needed. So it may be sometimes more or less also. So this may result in wastage of water or insufficiency to the crops. So here in the case of automated mechanism, what it does is it automatically sends an alerting message to the farmer when the moisture level increases or decreases, so that automatically the water level is being maintained. Then you have pest management and the control, where here if you look at this image, you can see the leaves are being affected with lots of insects. Okay, so all these can be captured using the camera, and you can do some kind of using various image processing techniques, applying various image processing techniques and machine learning techniques. You can find out whether the leaf is being affected, and you can also tell it is affected by which kind of insect or which kind of pest, and you can also give some suggestions saying that these are the primitive mechanisms that needs to be applied. So often farmers' hard work are being destroyed by predators that result in huge loss to the farmers. So to prevent such kind of situation, the Agriculture Internet of Things as a system that detects a motion of predators using these kind of passive infrared sensors. This information can be used by the farmers to reduce the damage that is done by the predators. So this is an implemented method basically. So if you look here, this is a crop or the field. You have stored sensor values. All these stored sensor values are being collected. So it can be like soil moisture sensor, temperature sensor, humidity sensor, okay, crop monitoring values. Then you have stored sensor values from the PAR motion sensor. Okay, all these are being collected, given to the computational unit, and based on the computations that are being performed here, the decisions will be taken and that are being sent as SMS alerts and buzzes to all the people or to wherever it is supposed to be sent. Okay. So this is a soil moisture sensor, the sensor that will sense the soil moisture level in the land called as a soil moisture sensor. Then you have the passive infrared sensor that is being used in the agriculture for detecting the motions, to sense the movement of people or animal or any kind of object that happens at nights. Usually this will be very helpful. Then this is an Arduino. I think all these things you could have studied in your IoT sessions. Both the soil moisture sensor as well as the PAR sensor are being connected to the Arduino to perform some kind of action, and the Arduino will send the data to the database using some kind of Ethernet shield. And if emergency, it also sends a message to the user using some kind of GSM module. Okay. So we have the GSM module through which it also sends an alert message to the users. So some of the advantages and disadvantages, if you see, this is a cost-effective method. You can use the water in an optimized manner. It helps in sustain high yielding, and you have high quality crop protection. Disadvantages are need for each kind of soil type is to be calibrated. Okay, you have various types of soil. There are various soil types. So you need to find out for what kind of soil type, how much amount of water is needed. All these things are supposed to be calibrated. All these things are supposed to be learned beforehand. Okay. So there are many other applications in IoT in agriculture. So these are certain applications that are being given. The machineries that are also used for agriculture can also be automated. The drones can be used for some kind of field monitoring work. Okay, instead of monitoring the field, you cannot have a person 24/7 monitoring the entire field. So you can have drones which can monitor the field. Okay, then you have water sprinkler or water management system. Then you have the soil monitoring system. So all these things can be monitored, and it can be all the data can be collected, it can be processed, and decisions can be taken upon. Okay. So we can predict the soil moisture level as well as the motion of the predators. The irrigation system can be entirely monitored. The damage caused by the predators is also reduced in this case. It increases the productivity, it conserves the water, and it is a profit to the farmers. Okay. The next kind of application that I have taken is a smart healthcare application. So smart healthcare is the third application that I have taken. What are the new trends in this healthcare? If you look at the healthcare trend, the World Health Organization, the WHO, estimates that 40% of the resources are spent on healthcare are being wasted because due to some kind of old processes and systems that are being followed. Okay. Studies also reveal that a mid-sized private community hospital with 370 beds can accrue benefits of nearly 43 million over 5 years with more holistic IT capabilities. If you try to incorporate these kind of IT capabilities to the entire hospital management, then the profit of the entire hospital can be improved. It has been estimated that there will be approximately 50 billion devices that are connected to the internet and therefore to each other by 2020. So these are some kind of estimates that have been happening. So based on these estimates, it is well known that if any kind of hospital management or any kind of hospital can be made as a smart healthcare, smart healthcare building or a smart hospital, it will transform the entire health. Okay, so if you look at this, so here if you can see this is what a smart hospital is all about. Okay, so you have the mobile care services, you have the worksite clinics, you have wellness programs which are being broadcasted through telecommunications. Then you have the telehealth or the e-visit. You have hospital bringing the entire hospital at home. You have automated kiosks standing here and there in the hospitals which can be used by all the patients, incoming patients. Then you have the services. While traveling abroad also, it is possible for us to avail these hospital services. Then we have medical homes and care teams. Then we have home visits. So automatically it will inform the doctor saying that the previous home visit, after the previous home visit, it is 1 month and now it is time for another home visit for this particular patient. Then you have the retail clinics, you have home monitoring. So all these things can be integrated in an efficient and in an intelligent. Okay, so let us see how it can be integrated in an efficient and intelligent manner. A smart hospital also helps to achieve intelligent hospital infrastructure is one where traditionally separate systems share the information using the latest open protocol. Then you have environmental responsibility where consolidated energy dashboard which helps in the entire hospital management track and improve the environmental performance. Then you have patient satisfaction wherein the building management, the infection control, the nurse squad, the patient entertainment system, all these work together to create an optimal healing environment. Then you have the financial health where the security, the building management systems talk to one another to reduce the energy consumption in unoccupied rooms. Suppose if there are some kind of unoccupied rooms, when using these kind of smart building, it is possible for us to switch off all the machineries that are available in that unoccupied room so that you try to save some amount of energy. Then you have the staff and business efficiency, wherein you have asset tracking system and facility management, which share the information to improve the asset utilization and reduce the time spent locating the asset. So assets in the case of hospital can be anything, like it can be the assets can be nurses, or assets can be the devices, the medical devices also. So all these assets can be tracked. Suppose if only 10 ventilators are available, you can, using these kind of automated systems, you can track how many ventilators are in the usage and how many ventilators are not used at the current time. And you can also predict and tell maybe in the next month there will be more usage of ventilators, so you need to have some extra ventilators that needs to be purchased or something like that. Similarly, for the nurses also, it will take care of the entire nurse timetable, saying that these many number of nurses are there and these are the nurses that are allocated to each and every patient. So all these things can be automated in an efficient manner. Okay, in the case of a smart hospital. Then you have security and patient safety, wherein you have access control, okay, infant tagging, CCTV. Then you have the lighting, which try to work together to improve the hospital security of the safety. Hospital security and safety can also be monitored using these kind of CCTV cameras and other things. And all the videos can be collected at one end. It can be automatically, it can be the videos can be processed, and you can find out whether some kind of mishappening is occurring, has happened, or something has happened to some kind of patients, or whether there is some kind of needy response that is needed. All these things can be tracked. So some examples for smart healthcare system. This is a hospital reception in an automated manner. If you look at this, you can see the hospital reception launch, which is secured with the surveillance cameras with the night and day vision with the event recording for hospital safety. So you have cameras fixed here and there, which is automatically going to record what is going to happen in the hospital reception. Then you have access controls for entry using latest in biometrics. So entering into some kind of rooms can happen only with the help of biometric devices. So if he is a nurse, he is supposed to enter into some specific room. If it is a doctor or a surgeon, they are supposed to enter into the wards and all those things. So these are being tracked using with the help of biometric devices. Then you have sirens and flashes with announcements of security breach and intruder alerts. Then you have 12 lines of defense and burglar security. You have the security module, which provides an alarm event recording, support recording of all the alarms in the history in case of violating the security zones. So the convenience of the hospital communication with the public address, the multiple inputs with private paging system, the announcement for nurses and doctors, paging with multi-room audio systems. All these happens at the hospital reception room. Okay, so this is like a smart hospital reception room. Then inside a particular room, what is going to happen? If you look at inside a particular room, it is elegance with compact integrated function, a new generation of door panels for hospital rooms, which indicates the room number, the doorbell for visitors, the patient's rest time, the cleanup room display, and the nurse call display. Everything is available. Okay. The inpatient hospital management is also designed to take care of all these activities, and it provides a comprehensive data pertaining to admission of patients, doctors, and nurses' notes. All these are being displayed here and there. So you have display boards inside the room itself to tell at what time or on which date this particular patient has entered into that particular room, and what are the medicines that are given to that particular patient. So the EHRs, everything are being tracked, automatically tracked, and are being displayed here and there. So this is a private patient's room. So you can have here also, you have some kind of hospital, smart hospital bedside controller, which gives the patient control on all the rooms, the needed devices for lighting and dimming blinds, the HVAC system, the TV with language selector, and then you have the RFID technology that is being adopted in many business fields, especially in the medical field. So this system also uses RFID tags. So RFID tags can be stuck to the patients. Okay, so usually it will be put in the patient's hand, or it can also be put in the form of a necklace around the patient's neck, so that using automatically, whenever the patient is taken from one room to the other room, automatically the patient is being tracked. Okay, not only tracking, you can also monitor the condition of the patient, and you will also know what kind of medicines are being given to the patient, and all these things can be the history, the drug history, the medical history of the entire patient can be tracked. Okay, so this is a patient tracking system. Then this is a smart hospital wardroom. So if you look at the smart hospital wardroom, you have ward management, that is availability of beds, how many beds are available, the estimation, agreement preparation, the emergency admission, shifting from one ward to another ward, the bed availability, surgery, administration of drugs, all these can be done in an automated manner. The dynamic wall panels also control the scene and the ability to dim the scenes. Okay, as I said, you can dim the lighting and all these things as per the preferences of the patient or the doctor, whoever is inside that particular room. Okay, so you can set your mode, the cooling or the heating, the fan speed, everything can be set up automatically. Then this is a smart emergency room. The outpatient emergency patient system, they support the doctors to take better and timely consulting decisions by providing instant access to comprehensive patient information. There will be instant access to all the patient's information, and they also handle requests and results of lab tests and other examinations are handed over in an immediate manner. External doctors also visit to inpatients and can be defined as on-call. The system register for patients for room transfer and hospital admittance, and view initial doctor's advice for all the incoming patients. Everything can be tracked. Okay, so this is a smart emergency room. Then this is a nursery room where you have controlled room temperature with sensors, where the kids are being placed. You have the controlled room temperature with sensors, which automatically shuts off the AC when the temperature goes beyond a particular level. And then you have the curtains, room curtains opens and closes at set time for the baby viewing time as well as a nap time, turns on and off the lights at the desired time for the bedtime as well as a viewing time. Then you have the smart hospital management system, which will keep track of all the patients' records as well as a medical history. So then you have the smart bathroom, which is also equipped with emergency button. Okay, smart bathroom is equipped with the emergency button to call and alert the nurses for some kind of emergencies. You have toilet seats, sanitizers for patients' hygiene. You have LED lights and LED faucets, control lighting system for energy saving as well as for elegance. Okay, so this is a smart healthcare kind of system where we have seen the entire hospital administration is being integrated in an efficient and in an intelligent way. Okay, so the last kind of application that we are going to look at is a smart education system. So if you look at the smart education system, let us have a close look at one of the survey that has been taken in the year 2017. So what are the educational institutions using or planning to use the IoT for? For what purpose are the educational institutions planning to use the IoT? So if you look at this here, if you see the physical building security, that has got the maximum thing, 60%. Then around some 57% is a smart automated building implementation. Video surveillance comes to about 50%. Ease of use for customers and employees comes to about some 47%. Monitoring of things comes to about some 45%. And the least one, if you see, is the usage of data to increase the productivity. Okay, so now we are going to look at how these IoT devices can be used in the education scenario in the schools as well as in the colleges. So you have the IoT camera, which will be helpful for taking some kind of automatic, which will be helpful for an automatic attendance system. Then you have the student ID cards. So these are RFID enabled cards, which can, or smart cards, which can be used, which will be helpful in tracking the individuals or the students. Then you have the school bus tracking mechanism with the help of a GPS tracker. You will know where the school bus is exactly coming. Okay, the parents will know, the students will know, as well as the school management will know. Then we have IoT pen. Okay, a pen, this kind of IoT pen, you can think of anything, like the pen will also wake up the student when the student is not feeling, like when he's feeling sleepy, it will try to give a jerk to the hand, telling that you are try to awake, so that the student awakes and writes a test or listens to the class. So this is one kind of IoT pen. Then you have interactive whiteboards, smart boards, which are helpful for some kind of presentations. Then you have the multi-touch table. Using the table itself, they can touch and they can see, they can feel, or they can do all the experiments in the multi-touch table itself. Then you have the smart podium. Okay, so the podium itself is a smart podium where you have the display board in the podium, which tells that who is the person who is standing there, or it has automatic video tracking and all these kind of mechanism. Then you have the attendance tracking mechanism. So these are some kind of examples of example IoT devices that are being used in the schools. So in the case of education, who are the main actors? If you look at the main actors in the case of education, we need to look at the student, the professor, as well as the administrator. So let us see how all these, the student is going to be a pupil, scholar, or a learner. The professor is going to be the teacher or the instructor or the tutor or the educator. Then for the administrator, it is the VC or the principal or the dean or the director or the HODs. So let us have a look at how all these people are going to use these kind of AI-enabled IoT devices. Okay. In the case of a student, what are the potential benefits of IoT for a student? In the student perspective, if you see, you can have adaptive or personalized learning. So you try to, the teacher will know the learning capability of each and every student, or the tablet will be, the study tablet will be enabled in such a manner that it will know what is the capability of that particular student. Based on the student's capability, it will provide the lessons to the student. That is an adaptive or personalized learning scenario. Then you have just-in-time learning scenario, where suppose if he has a doubt, immediately just at that moment itself, if it clicks automatically, it will tell that these are the things, this is a meaning of that. And then it also refers to making learning available when needed by the student at the time that the student needs the information or the knowledge. He can also have a personal assistant to help. So each and every student can have a personal assistant, but like nowadays we are talking about personal digital assistants, isn't it? So some kind of personal assistant can be there to educate the student, a personal tutors can be there to educate each and every student individually. This will increase the student engagement, and it improves the outcome of each and every student. If you look at the professor, there are better tools to explain the subjects and theories. In the case of involvement of ICT or IoT in education, there are better tools that are used to explain the subjects and theories. I'll also show certain examples. Then it will also help the professors to run the educational activities, various educational scenarios. You can have a better engagement. The professor will have a better engagement. It reduces the administrative procedures like attendance tracking. Attendance can be automatically tracked. The professor don't need to take the attendance. Then you have better tools for measuring the students' performance and achievements. Students' achievements and performance can be measured automatically. There are better tools to elaborate the experiments, like improve the teaching in STEM areas. Okay, there are various better tools that are used to elaborate the experiments or the labs. Okay, then in the case of an administrator, what are the potential benefits of this IoT with respect to an administrator? If you see the smart buildings and the better management of equipment and resources, it is possible for the administrator to manage the entire building in a better way, provides a safer learning environment, also provides a safer learning environment, enriches the LMS content, and also lowers the cost of the STEM labs. Okay, so IoT allow the creation of context-aware and ubiquitous learning environment known as smart learning. What is a smart learning? Smart learning is detects and takes into account the real-world context and multiple personal factors like learning needs and preferences. Okay, so context-aware computing of the ubiquitous learning environment is one wherein it will detect and take into account the entire real-world context in which location that particular student is. Because nowadays we are talking of the people are not coming to the schools or colleges to learn, isn't it? Previously, it was like the school was a place where all the people will come and the teacher will come to school and the teacher will take class. Nowadays, everything is in distant mode only. The kids are sitting at their home, they are listening to the lectures, they are listening to the classes. So if that is the case, then for each and every school, how is it possible for the instructor to provide the information individually to each and every student and to see to that every student understands the information? Okay, so that becomes highly difficult in the current scenario. So for that, we have context aware and ubiquitous learning environment, which will detect and take the entire real world into account. So we'll know the environment in which each and every student sits and studies, and based on the environment, you try to provide personalized information, a personalized e-content is being delivered to each and every student in an individual manner. So you have it adapts a learning content for the individual student, and it provides personalized feedback or guidance. Okay, you try to provide personalized feedback or guidance to each and every student. It interacts with the student via multiple channels like mobile devices, wearable devices, or other ubiquitous computing devices which are embedded in everyday objects. So it is possible for us to talk to the student, for the instructor to talk to the student or to understand the student much better by the help of lot of devices like mobile devices, wearable devices, and any other kind of ubiquitous computing devices like your IoT pen, or it can be anything. Okay, so affective computing is another one interesting area. Okay, where it is possible for us to provide some kind of personalized content or personalized material to each and every individual learner. Okay, effective computing, it is a study and development of system devices which can recognize, interpret, process, and simulate the human effects, okay, the human senses. It is an interdisciplinary field spanning the computer science, psychology, and cognitive science. Here, in the case of effective computing, the professor or the instructor will know the psychology of each and every individual. Okay? He will know what is the preference of that particular person. He will know what is in what environment that particular person is at that particular time. The professor or the instructor will also know what is the mood of that particular student. So based on the mood, based on the environment, and based on the learning pattern of that particular kid, it is possible for us to provide some kind of personalized content. That is what your effective computing is. Sorry. So at the entrance of the school in the classroom, the school attendance is being automatically tracked. And inside the school, you have airflow or air quality, temperature, humidity are being measured. Outside the school, the buses are tracked. So these are all nowadays not being used because everything is being done in a distant mode. You have smart identity cards, you have biometric clocking devices to improve the teacher's attendance. These are some kind of wearable technologies that can be worn by the student. Okay, some kind of like IBS, the wristbands, the tokens, the clip-ons, the jewelries. Okay, you have wearable cameras, you have hearables. Like hearable is another one, wearable which is being placed in the ear. Then you have watches. So all these are certain wearable devices which are being tracked, which will help in monitoring the student basically. So if you look at the way wearable technologies, these can incorporate a wide variety of sensors for measuring the position, displacement, acceleration, and force, the acoustic information, the biological information like the heart rate, temperature, the neural activity, and the respiration rate, the optical information like the refraction, light wave frequency, brightness, luminance, and the environmental information like temperature, humidity. All these things can be tracked using these kind of wearable devices. With respect to the contextual information, it is the ability to provide the contextual information. This could include giving the student the ability to search for additional background information using links to the real world to trigger augmented events. You try to trigger some kind of augmented events or try to provide some kind of links, searchable links to the students. recording of information, the student would record not only class sessions, but also could use these kind of wearable technologies to know what they are doing, either as individuals or as a group. The wearable technology can also be used to automatically scan and index the notes that are being taken in the class. Okay. Then it is also helpful in the wearable technologies are also helpful in the simulation as well as communication. In the case of simulation, it could enable the students to experience riskier scenarios and perhaps use them without suffering real world consequences. Like simulation scenarios, including surgical procedures, providing a working engine of any size, enlarging and manipulating the very small objects. All these things can be done with the help of simulation environments. Other simulation softwares that are available, and these can be provided to the students. Then in the case of communication, it includes the opportunity to integrate the communication streams into the daily work routines of study and participatory learning. For example, the students can work together in the field of study, study tools of institutions or work placement, all these things can be done. Okay. So feedback can be, individual feedback can be provided to the professors, and these individual feedbacks can be analyzed automatically and the results will be shown to the professor so that the professors will act accordingly. So the issues that are related to the use of these kind of wearable technologies are the privacy is being affected actually, the cost, it will distract the users, there may be some kind of technical problems, cheating can also happen, there will be over-reliance on these kind of wearable technology, and technology comes before pedagogy, so your studies goes takes a back when compared to this technology. That is also one kind of issue related to wearable devices. Okay. So another one important thing that I would like to stress in the case of IoT in education is augmented and virtual reality, which is being used nowadays, which is being used in all the educational scenario. Okay. So what is this mixed reality continuum? It's a spectrum which covers all possible variations and compositions of real as well as a virtual objects. I try to combine the real as well as a virtual objects. So on the spectrum, beginning from the far left, if you see, this is in reality, it looks like this. So you try to bring in some kind of augmented people or virtual objects into the real life scenario. From left to right, if you see, the left hand side is a full reality and the right hand side is an entire virtual reality where you try to create a virtual environment of the entire real life objects. Okay, so this is what your virtual reality is. In the case of augmented reality, you try to bring in some kind of virtual objects into real world. In the real world itself, you try to bring in virtual objects, you call it as augmented reality. In the case of virtual reality, you say you try to bring the real world itself as a virtual world. So augmented reality brings the aspect of virtual world into the real world. It uses the AR uses remain in the real world while experiencing enhanced virtually created visuals, audios as well as the feelings. The AR does this by layering the virtual information or graphics on top of the user's view for a real kind of scenario. So if you see, there are different types of AR technologies. This is one handheld kind of technology where you just look at you place your mobile phone over a particular location. It will tell, so it will in 33 meters, there is a restaurant that is available, that is a hospital that is available at 250 meters. Then you have a coffee shop at about 12 meters. Okay, there is a school is about 56 meters. So all these things will be a Wi-Fi station. So all these things will be shown, okay, in a virtual. So it tries to embed the virtual objects in the real world, basically. So this is also another one type of AR technology, that is a wearable AR glasses. If you try to wear this AR glasses, it will permit you to display some kind of 3D objects and information in front of the user. So the user can manipulate the object, or he can interact with the object with a kind of so this is also another one example, which is a spatial AR, which tries to permit a display and augmentation directly in space or any kind of objects. It's based on many technologies such as projection displays and holograms. So you try to project the entire phone onto your hand so that whenever you want to make a call, you can just use your hand to make a call. Okay, so the entire projection system is actually in your fingertip, basically. So we're using this projection technology. Similarly, hologram technology is also available, wherein you can make a person talk to another person in a virtual mode itself, but he will have a feeling as though he's talking to the real person. Okay. So then these are all AR technologies. Then you have the VR technology, which is a medium composed of interactive computer simulations that sense the participants' positions and actions and replace or augment the feedback to own senses, giving the feeling of being mentally immersed or present in the simulation. So you will have a real feeling of immersion in the environment. Okay, in the case of virtual reality, it tries to create a virtual space itself where the user will have the feeling as though he is immersed in the imaginary virtual space. So that is a virtual reality wherein you need to have some kind of head-mounted devices or the wearable devices that are supposed to be owned to have a look into these kind of VR objects. So you have desktop VR displays, that is a computer that has the ability to generate stereoscopic, some kind of computers have the ability to generate this kind of stereoscopic devices, stereoscopic displays, so that it is possible for you to see the objects or the animations coming out of the computer itself. Okay, then you have head-mounted devices of the gear VR boxes, which are adapted to individual users, and they adapt the image by tracking the, whenever I try to move my head or the eye, automatically that will be tracked and the object will also move as per my head movement. Okay, then we have workbench trackers, which operates by projecting a 3D image onto a table surface that is being viewed by a group of users, and using stereoscopic glasses, it is possible for the users to observe a 3D image that is being displayed. Okay, so nowadays this is actually very helpful in education, where particularly in the case of our medical students, wherein the medical students can learn the internals of the entire anatomy of the human being, because nowadays there is a lot of scales and cadavers that are made available to the medical students. So with the help of these kind of mixed reality techniques, it is possible to have the virtual human being itself in front of the medical student, so that he can do the surgery on the virtual object, and he can n number of times he can do the surgery. Whenever he does a mistake, you can also make this as an intelligent application. So whenever he does a mistake, automatically blood oozes out, or it gives a feedback to the surgeon saying that, to the medical student, saying that he has done a mistake and the surgery has to be done in this manner, which he cannot implement it on a real human being, isn't it? So all these are some very interesting technology advancements that are being used in educational field nowadays. Even in the case of experiments or doing some experiments in the labs, you can do it in a virtual environment, so that you can do and see yourself n number of times. It's not necessary that you have to go to the lab and do it. The lab will come to your location, so that you can sit in your place itself and you can do the experiment and see virtually, and you can learn everything. So AR/VR permits the learning situations that are too expensive to implement in reality. In reality, it is very expensive, so you can implement it using AR/VR. It is also dangerous, like chemical or radioactive experiences. All these can be simulated using this AR/VR environment, where the internal structure is important to help understand the internal functioning of a machine, the internal equipments, of the machine, or the internals of the human body. Everything can be shown to the end user. The phenomena are not normally visible to the eye. Some phenomena which is normally not visible to the eye, like macroscopic or microscopic phenomena, the molecular motions, the astronomical events, everything can be simulated in the form of AR/VR educational environment, and that can be given to the end user. So where phenomena are very fast or very slow phenomena, like explosions, drift of continents, and then some of the applications where you need to explain the abstract or complex concept, you can use this AR/VR technology in handy, and you can develop some kind of AR/VR applications which will be helpful for the students. But the limitations of these kind of AR/VR systems are, they pose a problem for lesson administration, monitoring the students' progress. And then some systems are beyond the scope of the school budget, because whenever you want to have some kind of AR/VR environment, you need to have a separate room, separate mixed reality room, or a VR room, wherein you will have all the projectors, the display devices, the head-mounted devices, another kind of sensing devices like hand trackers, the hand gloves, and all this, the motion trackers. All these are needed to have a VR environment, which is very costly basically. Social isolation of the students also happens who are not aware of their real surrounding environment. Difficulties of the professors to redefine the objectives of on-the-shelf AR/VR systems. And other limitations are like your health issues and technological issues. Distraction issues also happen. Health issues like whenever I have a hand gloves, I use a hand gloves to try to grab an object, or sometimes it may even hurt my hand. Okay, it gives a force or a pressure which is being sensed by me, which leads to some kind of health issues also. Okay, so this is one VR lab. I think you can just when the PPT is being shared, you can just go to the YouTube and you can see a wonderful virtual lab is being given here. You can see how the students are using this virtual lab to do the experiments on their own. So in summary, if you see technologies such as this AI and IoT, or they are potential disruptive or digital disruptive technology, which are going to entirely turn the present day scenario. This also results in new opportunities for collaboration in the fields of mobility, healthcare, industry, development of a digital infrastructure. The real concern is how the IoT and the AI will be able to defend itself from threats, because there are lots of threats like digital threats, security threats, and all those things. How they are going to defend themselves. Development and adoption of standards for AI security is also another most important. So these are the references or the slides that are being taken from all these places. Any questions?
Participants, you can unmute yourself and can ask questions. The session is open now. You can ask the questions, participants. Or you can post your questions in the chat box also. Madam is ready to answer. The session is open now, participants.
Good morning, ma'am.
Yes.
Pratibha from Saira.
Yes.
It was really a very good presentation,
Thank you,
ma'am.
ma'am.
And you had covered all the areas of IoT application, and I
Yes.
felt the new thing was education, towards education. What are the applications?
Yes.
So I got a good insight from your presentation.
Thank you, ma'am.
And one thing is with respect to agriculture, ma'am.
Yes.
Like what are the we know that it is what are the applications you have said is like they have
Crop
been
monitoring, irrigation,
yeah.
pest
So
control.
with respect to machine learning, what are the novel things that we can use in IoT, ma'am?
Yeah. Nowadays, some of the interesting areas where machine learning techniques are being used in agricultural IoT is the pest control, basically. As I said, you try to get the images of the plants which are being affected with the pests and insects. Okay, and then you try to apply various image processing techniques, use various machine learning algorithms like your RNN or CNN or whatever it is, and then you try to find out what kind of disease it is, or what is the type of disease that that particular leaf is being affected. Especially in the case of Coccus nociferanda, they use these kind of techniques. Okay, even in tomato plants and other things.
My question is, ma'am, when we have to use this machine learning algorithms, specifically how to choose a particular machine learning or a deep learning algorithm when we are applying, let us say, for a pest control, this one.
Yes, it depends on what kind of features that you are going to look at. Say, for example, if it is a tomato leaf that is being affected with some kind of insect, with the color itself, it is possible for me to identify. Okay, so it depends on what kind of disease that you're going to look at. It depends on what kind of plant that you're going to look at. Okay, so you can use the initial features like color, the color of the leaf, whether it has turned into yellow or gray color. Only the color itself will give lots of information. Other than that, you can also go in for some extra features like HOG features and other things. Okay, so which will also give lots of insights into the data that you have collected from the diseased plant. Okay, so it depends on what kind of disease that you're going to look at, and it depends on what kind of plant that you're going to look at. So just like that, we cannot tell that for these kind of diseases, these are the machine learning algorithms that will be helpful. Okay, so that in that case, you have to look in for some kind of literature in that specific area. Okay, madam, have I answered your question?
Thank you, ma'am.
Have I answered your yes.
Yeah. Thank you very
Yes.
much.
Ma'am, there is one question in the chat box posted in
Yes,
the
sir.
chat box. When the farmers are using these user-friendly tools, how can they use it? And since the farmers are
Because
uneducated, how can they?
most of the farmers are uneducated. How are they going to use it?
Yeah.
So nowadays, the kind of tools that the agricultural institutions are giving to the farmers, they give it in their own regional language itself. Okay, as I said there is an Uber-like app for tracking the vehicles, agricultural vehicles, where the goods are coming or where the vehicle is, to track. So these are being given in the regional language itself. Okay, so that they can even through phone calls itself, the farmers can talk to the experts, okay, and get certain ideas. Not necessary that they have to go in and use all these kind of techniques that are available. If they are very uneducated, they can also use their own language to talk to the experts. There are also expert systems based on that. Many expert systems that are available even in Tamil Nadu Agricultural University. They have used currently they are using lots of expert systems which will give some kind of advice to the farmers, even if they just make a phone call through some kind of toll-free number. That is also possible.
Excuse me, sir. Kindly open the chat box, please. Chat box is disabled.
Yeah. Okay. If you want to ask any question, you can ask Madam straight away. Chat box will be open now. That's not a problem. If you want to ask any question, you can ask the question. Madam is there to answer. She is ready to answer. Do you have any queries? Participants, do you have any queries?
Hello.
Yes, sir.
Sir, attendance link is not found here. So chat box is disabled here.
Now it's enabled, sir.
Yeah.
If you have any
Sir,
questions, you can post.
In my system, that is showing disabled. Chat box is disabled.
Now it's enabled, sir. You can go ahead. If you have any questions, if you have any queries, you can.
Okay.
If you have any queries,
No,
you can
sir, no.
post. Do you have any questions?
Sir, kindly provide me the links, speakers, materials links, so that we can download and.
That and all we will provide, sir. That and all you can come to offline mode and ask. Okay. Now the session is going on. If you have any questions regarding a session, you can ask, sir. Sorry.
Okay.
Okay, ma'am. I think.
Yes, sir.
It's time to facilitate. Dr. Meena Kabilan, ma'am, will facilitate.
Hello, ma'am.
Yes, madam.
Good morning,
Good
ma'am.
morning, ma'am. Good morning.
1 minute, ma'am. Ma'am, thank you. Thank you so much for your valuable talk to our participants,
Thank you, ma'am.
even in your busy schedule.
No problem.
Thank you, ma'am. Thank you. Thank you.
Somebody has written that, ma'am, please go slowly. I did not see that in the chat box. We are not able to understand. I went in a jet speed to cover all the applications because I have taken 3 or 4 applications now. So I thought I should cover all these applications. I should not miss anything.
You are expert in many fields now, ma'am. So you can't able
Like that. Fine, sir. Thank you.
control your speed because you plan to cover all the areas.
All the
That is-
areas.
That
That's
is the things.
Thank you.
Thank you, ma'am. Thank you.
Thanks, sir.
Immediately you accept our invitation, even though if it is not in your field.
No problem.
Thank you.
It was a nice experience for me also.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Shall I
Kindly,
leave?
kindly send your presentation to my mail ID, ma'am.
Sure, ma'am.
We have to be uploaded in your portal.
Yeah, immediately. I will send.
Thank you.
Okay, ma'am?
Thank you so
Shall I
much.
leave?
Thank
Thank
you.
you.
Okay, thank you. Thank you. You can leave.
Thank you, madam.
Thank you, sir.
Thank you, madam. நீங்க சொல்றீங்களா? Okay. Participants, don't leave. there are a few things to be clarified clearly from the ATAL coordinating team. Actually, this is the third day. Okay, this is the third day, and you have almost 6 sessions have gone. Okay, 6 sessions have been completed. Today morning is the 7th session. Okay, we are going to freeze the attendance